Introduction to C++. That sounds pretty good. What are we supposed to be studying in this class? Well, good, because it'd be awkward if we were doing something else, right? Bam. All right, so what's in a name? C++, what a stupid-ass name. Why didn't they come up with something cool like Snowflake or Firetruck or whatever? Anyway, so here's the scoop. So the C programming language was developed by a little guy named Dennis Ritchie. He's really super famous, by the way. He worked at Bell Labs, which is a place where super smart people work. And he wanted to, so the interesting thing, he had a little problem. So he had this dinky old DEC computer, which is fantastic and wonderful for the time. And he was running the Unix operating system on his dinky old computer, okay? Well, time marches on, and the good folks at DEC came out with a brand new computer. And the brand new computer had a brand new CPU with a brand new instruction set. So he has his old computer, and then of course he's at Bell Labs, so they get all the really cool new stuff. So he's got a new one, and it sits there. He goes, well, I love the Unix operating system. So what I'd really like to do is move the Unix operating system from my old system to the new system. Unix operating system completely written in assembly language. Okay. So if he's going to do that move, he's basically got to recode the whole dang thing. And he's like, ah, well, first off, that sort of sucks as a task. Well, what do you think the good folks at DEC are going to do in 6 months or 12 months?
Make a new computer.
Make a new one. So not only does he looking at moving it once, but he's looking at moving it like a million times, right? Every time they find out with a new one, he's going to have to do the whole, figure out what the new assembly language is, and stuff like that. So Dennis Ritchie's a smart guy. He goes, wow, that sucks. I don't really want to spend the rest of my life doing that, porting Unix to new computers. So there's got to be a better way to do it, and he is actually correct. There is a better way to do it. What he does is he invents the language called C. What the heck's up with that? So he takes Unix, and he goes back and he rewrites Unix, but he rewrites Unix in a high-level language, C. Okay? Well, once he's rewritten in C, then when the new computer shows up, which it already has, all he has to do is go to the new computer and actually write a compiler. Well, writing a compiler isn't that big of a deal, right? But if he writes a C compiler for that machine, then he can show up with his Unix files, compile them, and poof, all of a sudden he magically has Unix that runs on that computer. And in 12 months, when DEC shows up with a brand new computer, all he really has to do is create a brand new C compiler. Once again, not that big of a task for that new computer, and he can compile Unix and get Unix to run on that one too. So Dennis Ritchie is a really super smart guy. He's also a really talented programmer, quite obviously, right? So he was pretty good at stuff like that. By the way, yes, there was a D language, but it sucked, and so that's why they created C. Okay, C is available for most computers, and it is hardware independent. One interesting characteristic of C, not C++, but C, is that it runs really fast. Okay? From the get-go, it's not that far removed from assembly language. Yes, it is a higher level language. Yes, you get to get things and stuff that you can read and stuff like that. But the whole concept behind C has always been that it produces code that runs super duper fast. So if you see projects that are coded in C, there may actually be a real reason for it because they need an end result that moves very quickly. Widespread use of C with various kinds of computers, sometimes called hardware platforms, unfortunately led to many variations. And they said, whoa, this is crazy, we're starting to splinter, basically. So a standard version was needed. The American National Standards Institute, ANSI, cooperated with the International Organization for Standardization, ISO, and they standardized C. So now we know what the C language is. Okay, everybody agrees on it. There's really only one version of it. Fantastic and wonderful. C++, which is what we're going to be talking about, is actually an extension of C. So you got assembly language, you got C, and now you got C++. Basically what it is C with objects. Effectively is what C++ is. Okay? It was developed by this guy, who we don't even say his name, okay, in the early 1980s at Bell Labs. So 1980s, how long ago was that?
30 years ago.
It was about 30 years ago, right? But that's not that long. I mean, it is a while ago, yeah, but it's not like a million years ago or something like that. But what's interesting is like objects and stuff like that didn't really exist before the 1980s. Right? Oh, that's sort of interesting. Provides a number of features that spruce up the C language, but more importantly provides capabilities, oh, here we go, object-oriented programming. Now you guys have taken the Python class, right?
Right.
So you know how to write a program, right? If I showed up and said, hey, write something in Python, you can make easy, hard, whatever the scoop is, you can sort of pound it out in Python, right? Fantastic and wonderful. And that is good. Those are critical skills to have, no question about that. It's a very specific type of programming, though. One of the challenges we have is I show up and I say, hey, listen, I'm creating a brand new spacecraft that's going to take people to the third moon of Jupiter, which is a project that's about this big. You would struggle because you'd be coordinating your efforts with what, 1,500 other programmers, right? They'd have to remember what you're doing, you'd have to remember what they're doing, and just things get out of control really quickly on a large-scale project. And so that's where objects and all this other stuff come in. It was designed for allowing us to do really, really big projects. All right, so what do you have to do to learn C? Well, you got to learn the C language, yay! But you should also learn how to use classes and functions in the standard library. Standard library is just a bunch of stuff that's already been created. It's out there, it's for you, you can use it, okay? Other people made it, it's really, really good code, but it extends the language and gives you a bunch of stuff to do. 1 and 2, and you're good to go. Bam. Typical C++ development environment, of course, you have an editor, so you can enter your program. You'll, of course, save it on a disk, someplace like that. This, for example, is a standard C++ output program. So we've got just a little bit of text here, got some code right there. So step number 1 is you write the program. Step number 2 is you run it through what's called a preprocessor. A preprocessor takes a look at your code. It's not compiling, but it's taking a look and it's trying to find out if you put some special control statements in it that ask it to basically bring in other files or do stuff like that. So really what it's doing is taking your code and it's building what it's actually going to end up compiling. If you say bring in some libraries, it brings in those libraries and it extends your code, okay? Now we actually go ahead and compile the program. Hey look, 0s and 1s, all right? That's exactly what we're expecting to have. So that's exactly what the compiler does. It takes your nice, easy to read code that you produce and produce the incredibly hard and difficult to read 0s and 1s. That's exactly what the CPU wants to process. And then finally we do what we call linking. Now what linking is, it's basically, it's resolving all the addresses. If you say the array is here, let's figure out exactly what memory location that array is at. If you say this function is here, let's figure out exactly where that's at. So after we've compiled everything, we're going to work out exactly where everything is located, and that's what linking is all about. Finally, what we're going to do is when you want to run it, we're going to load it. So obviously we'll suck it off the disk, we'll put it into loader, it'll actually put it into primary memory, and it will also say the start location is located right here. Okay? So let's talk about why we're going to do all this object-oriented stuff. So look, procedural languages such as Python, which you should be intimately familiar with at this particular point in time. If I'm writing a Python program, I start here, I go to the middle, and I go to the end. It's procedural, right? Okay, hopefully it solves my problem, I'm good to go, I've got a single file, life is grand, right? Okay, we've got no problems with this whatsoever. Now what's interesting about this code is that we have both our code and our data is all work together, right? If we need something, we use it. If we don't need something, we don't use it. We've got all of our processing and stuff like that. There's no real separation between code and data in Python because it doesn't have to be, right? Okay? In the world of objects, that all changes, okay? We actually create basically separate pieces of code and data. And if the code needs the data, we put the data with the code. So we have code and data pieces all over the place. Okay, they're self-contained. We call these objects. Each object represents a different part of the application. So you give me enough objects, I put them together, bam, that's the whole program. Okay? Each object contains its own data and its own logic. Obviously, it contains the data that it needs to do its job, right? Okay? The objects communicate between themselves. Objects are designed to represent how you talk and think about the actual problem. Objects are meant to make thinking about your program easier, and object-oriented is just an idea that's supported by C++. Good news, object-oriented stuff is supported by Java. It's also, interestingly enough, supported by Python and a whole bunch of other languages. Objects is actually a pretty good idea, so it's been worked into most languages these days. Now, I already know how to program. Why are you bothering with the C++ stuff? Well, good question. Okay, why is so much attention today focused on OO programming? The answer is it allows you to build reusable software components. So let's think about this for a moment. If I was running a software company, okay, and I decided to build a brand new program, how would I want to do that? What would be a perfect world for me if I was going to build a brand new program?
Start from what you had before.
Start from what you have before. Okay, so yeah, you're really close to it. What I'd really like to do is walk into my software closet, right, where I keep all the software that I've created before, right? And I think about my new program and I say, well, I have to have a logon function. So I go reach up on the shelf and I take down a logon function. And after you log in, I have to show you all the stuff that you have. So I reach in and get this, show me all the stuff I already have. And then I need, security is important, so I need an authentication function. So I pull that off the shelf, right? You start to see what I'm doing? Am I doing any coding?
Nope.
I'm not, right? I'm just picking up stuff that's already been done, grabbing it and sticking it together in my program, right? And as a guy who owns the company, this is perfect. Why?
Less
less cost, right? You darn programmers cost me a lot of money. So if when I'm creating a brand new project, I always have to start from scratch, if I always have to start from the beginning, dang, that's going to cost me time and money, right? And those are two things that are way, way, way too expensive for me to spend too much on. So this whole object-oriented thing gives me the opportunity to say common things that I'm doing over and over again. I can do really well, call it an object, put it up on the shelf. And the next time I create a program, I can reach up on the shelf, take it down, and work it into my program, right? So if I'm building my rocket ship to go to the third moon of Saturn, well, fantastic. I'll pull down, I'll do the development, I'll put everything up on the shelf. And then if I decide, well, you know, I really want to go to the fourth moon of Saturn, or sixth moon of Saturn or something like that, guess what? I've got a closet full of stuff that's pretty good, right? I'm sure there's some differences for whatever that project is, and I will code those. But I've got, what, 2/3 perhaps of everything I need. How cool is that? In the world of Python, you're probably starting from scratch. I mean, you can take your program that you wrote to go to the fourth moon of Saturn, okay, but you're going to have to sort of step through it and figure out what you got and what you don't, and it's not going to be terribly clear. Okay? Building software quickly, correctly, and economically has been an elusive, in other words, we don't have it, goal in the software industry. The modular object-oriented design and implementation approach has been found, here we go, here we go, here we go, to increase productivity 10 to 100 times. And if I don't have to code it, bam, it's done. That's super productivity increasing, right? The over conventional programming errors, well, reducing the development time, errors, and cost. And the reason it's reducing development time, errors, and cost is because if it's already done, I don't have to develop it, right? And if somebody really smart created it, and you're going to work into your project, then you're using the best thoughts of somebody else in your particular project. It's already been debugged, it's already been worked out, you don't have to worry about any of that sort of stuff, okay? C++ is extremely popular because it's a superset of use of C. So if somebody already knows C, it takes almost nothing to learn C++. Of course, you don't know C, so we'll start from the ground. Boop. So let's talk about objects, since they seem to be such a big part of C++. What is an object? Okay, so objects, both software and real, have two ways they can be represented. Number one is attributes. Number two is behaviors. This is how they are, and this is what they do. Starts to get interesting. So, let's talk about your car. Does your car have a gas pedal?
Yes.
Mm-hmm.
And when you're driving along and you press on the gas pedal, what happens?
Car moves forward.
What's that?
Car moves forward.
Excellent, that's fantastic. How does that work?
The engine and drive combustion.
There's gerbils. And when you press on it, it presses on the back, and they go, ow! And then what they do is they open up, and then more gas. I've got no freaking clue. No clue whatsoever what happens. And that's exactly what we're talking about. The gas pedal hides the driver from the complex mechanisms that actually make the car go faster. Just as, oh my goodness, its buddy, its pal, its second cousin, the brake hides you from the complexity of however the heck your car happens to stop, right? Okay? Oh, by the way, the steering wheel hides the mechanisms that turn the car. We will agree that when you turn your steering wheel, your car turns, right? Can we all agree that there's probably a bunch of stuff that happens when you do that?
Yes.
Things that are connected to other things that turn other things that cause that wheel eventually to somehow turn, right? But you don't have a freaking clue how that happens, right? And in fact, if it broke, you'd be screwed, right?
Not necessary.
So apparently somebody did a good job. Oh, I'm sorry, not necessarily. All right, we're out to your car, we're going to take something off, and then you figure out what the heck went wrong, right? Okay. Okay. Now, why is this a good thing? Well, because it enables people, which is another way of saying you and me, with little or no knowledge of how engines, braking, and steering mechanisms work to drive a car easily. Man, just think about if you had to know all that stuff. That would sort of suck. Objects work in the same way. They hide your code from other developers so they don't have to know how you did something, just what your code does. So think about it. You code up a nice little object, it does something fantastic and wonderful. Let's see. I'm going to code up an object that verifies that somebody who's logging onto a computer is permitted to log onto a computer. That is my little object of code. And they provide what? An email address and a password. Okay? And if they provide it correctly, then they get to log on. And this is my object. And somebody else is developing something for that workstation. They say, hey, I need some security. I need to make sure that they can log on correctly. And I show up and I give them my object and say, here you go. This will do it for you. They can plug it into their code. Do they have to know how I do it?
No.
Absolutely not. My code is secret. You know, I'll just let them log on. I don't really do anything with my code. You know, whatever, okay? Maybe I reach out to some secret NSA database, or whatever the scoop is. I can do anything I want, but they won't know what my code does. I'm sorry, let me take that back. They won't know how my code does what it does. They will know what it does because I will tell them. It authenticates people trying to log onto the workstation. But I won't tell them how I authenticate it, right? And that's the value of an object. Member functions and classes. Performing a task in a program requires a member function, which houses the program statements that actually perform its task. What it means is that every single object does stuff. This is my thing, and it does something. Well, great, what does it do? It does member functions. So I'll have a series of functions that belong to the object, okay? The member function hides these statements from the user, just as the accelerator pedal of a car hides from the driver the mechanisms making the car go faster. In C++, we created a program unit called a class, you'll hear that over and over again, to house the set of member functions that perform the class's task. We'll get to this in a minute. Okay. For example, a class that represents a bank account. You all have bank accounts, right? Okay. And how much do you have in your bank account right now? That's not so good. Might contain one member function, to deposit money, as another member function to withdraw money. Does that make sense? So the thing is the bank account. The member functions allow you to do stuff with the bank account. Stick money in, pull money out. Okay, this is cool. Oh wow, and you can have a third one to say, yo, how little money do I actually have in my account right now? Oh, I'm sorry, I should tell you something else. You guys know about the Powerball thing?
Yeah.
And what is it? It's like the drawing's on Wednesday.
It's it to 1.3 billion.
I believe so. So I want to let you know, I am actually in possession of a Powerball ticket. Should my ticket win, the way we're going to play this game is no more class this semester, and you all get A's. Okay? But that's only if my ticket wins.
It's not likely.
Would you bite your tongue? I feel very good about my ticket. And I'd like to point out to you, Mr. Gedge, you can't win. Okay. That was just important because, like, if I'm not here, you'd be like, wow, you must have won. Okay. A class is similar in concept to a car's engineering drawings. Okay, yeah, so here's the concept. So a class is actually not an object. So we're trying not to get too whacked on it. Okay? So a class, when we say class, what is a class? A class in the world of C++ is just a blueprint. Okay? When I say, hey, here's a class, all I'm doing is saying this, if I ever created an object, this is what it would look like. I can show you the blueprint of a house. Is the blueprint of a house